Hey, GatMath students, this is a video notes for data probability and stat basics, objectives 130 to 134. So we're looking at basic probability today. So grab your packet. If you don't have your packet, hit pause, go grab your packet, and then you'll be turning towards the end to a page that looks like this. Okay. Again, we're going to be jumping around a little bit because I want to do each topic kind of in order. So we'll do a few problems of probability with single events and probability, and then a few of these and so on. So we're going to start kind of in order. We're going to start with number one. Not much extra notes besides just doing problems, but there is just a couple little things that I want to go over here. Some of this you probably remember, because I believe most of you have done some basic probability at some point in time. Basic probability is always going to be a fraction, or that's at least how you set it up first. You do it a fraction, and then you can change it to a decimal or change it percentage. But to find it, you're going to set up a fraction where the top is number of what they call favorable outcomes over number of possible outcomes. Okay, now favorable outcomes. Word favorable usually means something you want, but favorable in this case, a lot of times favorable can mean good. In this case, it's not necessarily always good. It just means what you're looking for. So you could find what's the probability of losing a game or something like that. And that's not necessarily a good thing, but it's what you're looking for. Okay. The other thing we'll put here, just as a side note, probability is always between 0 and 1. So probability of 0 means never will happen. Probability 1 is for sure will happen. This could also, if you do percents, this would be between 0% or 100%. So even though, you know, in life there can be percents over 100, but when you're dealing with probability, you can never have anything over 100. Or when you're dealing with just regular numbers, it cannot be over 1. Okay, so that's kind of your basic notes for basic probability. So let's look at a few of the easier problems. So again, when you're doing a test on this, there's going to be some really easy problems. So, you know, go through, do the easy ones first, and then go back and do some ones that are a little tougher. And I don't think there's going to be any that are super tough on here, but as you're going to see, some of these will be pretty simple. So number one says, you are one of 24 people entering a contest. What is the probability that your name will be drawn first? So a lot of times when I do this, you can do it either way, but I look for the bottom number first usually. What's the total possible things here? So if you are one of 24 people, so that means there's 24 people that are being chosen, and if it's all equal, if there's one name for each, there's 24 possible choices that could happen. Your name is in there first, or once, I should say. So you have a 1 out of 24 chance that your name will be drawn first. Okay, number two, still a pretty easy problem, maybe just a little tougher than the first one. It says a bag contains 2 red, 5 white, 3 blue marbles. What's the probability of obtaining a white or a blue marble on a single draw? So the first off, I look at what's the total. So 2 plus 5 is 7 plus 3 So there are 10 marbles. So on the bottom is 10. Okay. Now, probability of obtaining a white or a blue, that means either one of those are favorable. So we have 3 white, or no, sorry. It doesn't really matter if I put it at first, but we have 5 white and we have 3 blue. So let's say you were a winner prize if you got a white or a blue. Any one of those would work. So that means 8 out of the 10 would give you what you're looking for. Now, probability is usually going to be given in a reduced form. So look at 8 and 10. Look for a number that goes into both. 2 goes into both. So we can reduce that. 8 divided by 2 is 4. 10 divided by 2 is 5. Probability is 4/5. Okay. If you're not great at reducing fractions, you could change this to a decimal. 8 divided by 10 is 0.8, and then you just check these. Which one is, when you divide top divided by bottom, is 0.8, and 4 divided by 5 is 0.8. Okay. All right, we're going to keep just trying to fly through these. Afterwards, if there's ones I went too fast on, you don't get, just ask a question. A number cube, so we're going to number 6 here. Sometimes there's can be some that almost seem too easy, or they can almost seem tricky. It says a number cubed is tossed. Find the probability that of obtaining a number different than 8. Okay, so first thing, bottom number, a number cube. There are 6. And you can see a couple of these have 6 on the bottom, or even after reduce, you can always start with a 6 on the bottom and then be reduced afterwards. But a number cube is tossed. There are 6 numbers on, and that's called or a dice. They just don't use that. There are 6 numbers on a dice or a number cube. So the total possible numbers you can get is 6. Now, this could be seen as kind of a tricky problem. It says find the probability of obtaining a number different than 8. Well, a dice has numbers 1, 2, 3, 4, 5, and 6. Those are all different than 8. So all 6 numbers are different than 8. 6 divided by 6 is 1. That means you will, a probability of 1 means you will for sure get a number different than 8. Okay. All right, we're going to go back to the first page. Now we're going to be looking at what they call, looking at this objective here, probability of complement events. So complement events, it's basically the opposite of event happening, or if the probability of something happens, the probability of it is would be meaning it not happening. So if we wanted to find the probability of rolling a 1 on a dice, the complement would be not rolling a 1. So 2, 3, 4, 5, or 6. And one thing we need to know is the probability of an event plus its complement they'll always add up to 1. Okay, or in percents, 100%. Okay, so let's take a look at this problem. It might just be easier to do a problem. So it says, statistics from the past 10 years predict the chance of rain on any single day in April in Asha's hometown is 29%. Okay, so just not looking at the weather forecast or whatever, but just looking at the history, there's always a 29% chance that a day could have rain. It says if Asha's birthday is April 9th, what is the chance of it not raining? Okay, so 29% chance that it will rain. plus something has to equal 100%. This is the complement, which would mean the opposite of raining is not raining. So this would go right here. Okay, so you could look at this or you could do algebra, but basically what it means is you do the opposite and you subtract this amount, or in other words, you would take 100% minus the 29%, what's left over, and that is 71%. Okay, so if something had, just another example, if something had a 10% chance of happening, its complement would have a 90% chance of happening. Okay. Again, if I went too fast, that doesn't make sense, that's where you message me, ask me a question, I'll go over that with you. Okay, we're going to go to number 5, another complement problem. It says you work at a t-shirt printing business. Of 1,700 t-shirts shipped, 85 are printed improperly. What is the experimental probability that the t-shirts are printed correctly? Okay, so there's 2 ways you could do this. So with what they're looking at here, the numbers they gave us, 85 out of the 1,700 are printed improperly. If you divide that, it comes out to be 0.05, or move that twice, 5%. Okay, but we're not looking for that. We're looking for how many of them are printed correctly. Okay, that's the opposite or the complement of improperly. So if we just take the 100%, if 5% are wrong, we subtract, 95% have to be correct. Okay. All right. For the next example, we're going to go all the way to 22. Okay. So they have 6 balls numbered 1 to 6 are placed in an urn. So 1 ball is selected at random. Find the probability that it is not the number 4. Okay, now there's actually 2 ways that you could do this problem. The way they're kind of looking at you to do this problem is, and I'll show you the both ways. So we could find what's the probability of finding a 4. If they're 1 through 6, there's only 1 4 in there out of 6. So that's of getting a 4. So then use the complement. And 1 is the same as 6 over 6. And you would get that as an answer. Now, I think the numbers are small enough in this problem where you could easily just do this and say, okay, there's 6 numbers. I want the probability of not getting a 4. Well, one of them's a 4, and there's 6 numbers, so that means there's 5 that are not 4. And there's your answer. 5 out of 6 are not 4. So you could do that either way. Okay. All right. So we're going now all the way back to number 8. We're going to look at something called odds. Odds is, you have to be careful. There's only going to be probably 5 problems on the test that talk about odds. Odds are similar to probability, but slightly different. And it's slightly different. We're not going to get into it, but in gambling odds, if you're talking like the odds in Vegas or this and that, that's similar, but not quite. If we're talking about odds of an event, okay, it's similar. We're going to do favorable outcomes, which is the same as probability, but probability has total possible on the bottom. Odds has unfavorable. on the bottom. So the two, the top and the bottom together will equal the total possible, because it's either what you're looking for or it's not what you're looking for, and added together will equal the total. Okay, so if we look at this problem, a bag contains 8 yellow marbles and 1 red marble. The marbles are randomly selected one at a time. What are the odds? So right there, you know you're going to use this instead of the probability one, of picking a red marble on the first selection. Okay, so probability, this would be 1 out of 9 because there's 1 red out of 9 total. But odds, we're looking at, there is 1 red and there are 8 not red. In this case, yellow means the same thing, but and then a lot of times odds, they don't leave it as a fraction, they write out in words, and it's going to be the top to the bottom. So in this case, 1 to 8. Okay. Next, we're going to look at number 13. It says that odds against Pat winning the election are 4 to 9. It says with these odds, what's the probability that he'll win the election? So let's first break this first down. Odds against are 4 to 9. That means against winning means not winning. That means there's 9 that are winning, or 9 outcomes where he could be winning, 4 outcomes where he's not winning. Okay, because that's odds. Now they want to switch this. Instead of writing odds, they want to go to probability, which is favorable over total possible. Now, again, favorable doesn't always mean good or bad, and it could match up exactly with over here or might not. This was odds against, means not winning was the favorable. Now here, though, they want probability that he will win. So we want the outcomes where he'll win over total. Okay, so looking at the odds, 9 was the way he could win. So 9 outcomes where he wins. And total, well, there was 4 outcomes of not winning, 9 outcomes of winning. It would be 13 then. And it would be B. Okay. So again, you know, that one doesn't make sense. Maybe rewind it, watch it again. Okay. And then again, if it just doesn't make sense, that's when you message me and ask me. Okay. That's important. Okay. Let's look at number 16, another odds problem, and I think we're done with the odds. Okay, it's a very similar problem. This time they give you a probability. So probability of an event happening is 4/9. So that means 4 favorable over 9 total, because it's probability. Now they want this as odds. They want odds in favor. Okay, so they're keeping it the same. They're not changing it to opposite. If they said odds against, then we would have to switch it around. I can talk about that in a second. But if they said odds in favor, that's still 4. There was 9 total. Okay, so if 9 total and 4 were favorable, we'd have to go 9 minus 4. That means there's 5 left over. So this would be 4 favorable, just like here, and 5 unfavorable. And then top to bottom is 4 to 5. Okay, so odds can be a little confusing at times. Remember, there's going to be other examples here. If you're not getting the right answer, ask. Okay. All right. So now we're moving to the kind of the last group. We'll be doing number 7, but I just want to show you what the last two objectives are. We have probability of independent events and dependent events. These together are called compound events, meaning we're going to be looking at finding probability of more than one thing happening. So what's the probability of rolling a 6 and then rolling a 2, or rolling an even number then rolling an odd number, or you're dealing with cards, what's the probability of pulling a heart, putting it back, and then pulling a heart again. Things like that would be compound events. So let's take a look. We're going to go to number 7. And I got 5 problems left here. We're going to look at number 7. Okay, it says a bag contains 2 purple marbles and 5 blue marbles. 1 marble is drawn at random and not replaced. Okay, so that's going to be important. Actually, I think I'm missing a problem here. Yeah, we need to do number 4. We'll go back to that one. We're going to do number 4 here. Then we'll go down there. So same type of problem. A drawer contains 8 red socks, 6 white socks, 4 blue socks. Without looking, you draw out a sock, return it, and draw out a second sock. What is the probability the first sock is white and the second sock is blue? So the first thing, let's just look, what's the total number of socks? So 8 and 6 is 14 plus 4. We have 18 total. Okay. So the first, we want to know first, what's the probability of first getting a white? Okay, and then we'll talk about what we do with these two numbers after. So white, there's 6. And there's 18 total. Okay, so let's reduce this. 6 goes into both. If you didn't notice that, you could divide by 2, and then you divide by 3, or divide by 3 and then divide by 2. But eventually you'll get down to probability of getting a white on the first one is 1/3. Now you return that sock, and then we look at probability that the second is a blue. The reason it's key that you return it is now there's still 18 socks in there because you put that one back. Okay. Now they want to know what's the probability it's a blue. So out of those 18 socks, there's 4 that are blue. So 2 goes into both these numbers. 4 divided by 2 is 2. 18 divided by 2 is 9. So we got a probability that the first sock is 1/3, and then probability 2/9 that the second sock is blue. Now, probability of a compound event is found by multiplying the probabilities. Again, if this is too sloppy for you to read, kind of pause, rewind, listen. You'll know what the words are. By multiplying the probabilities of the individual events. So we found the first event happening was the probability of 1/3. Probability of the second event happening was 2/9. We multiply those. Remember, multiplying, you just multiply across the top, then the bottom, see if you have to reduce. So 1 times 2 is 2. 3 times 9 is 27. You cannot reduce. The answer is C. Okay. Now let's go to number 7. Same type of problem. A bag contains 2 purple marbles and 5 blue marbles. 1 marble is drawn at random and not replaced. That's important because then a second marble is drawn. What's the probability the first marble is blue and the second one is purple? So first blue. So again, we have find the total. So 2 purple, 5 blue, that's 7 total marbles. What's the probability that the first one is blue? 5. Okay, now probability that the second one is purple. Now the key here is it was not replaced. So we kept out, we're assuming we got a blue marble on the first one because that's what we want to happen. So there's not 7 marbles in there anymore. There are now 6 marbles. Okay, now assuming we got a blue on the first one because that's what we're looking for. Now we're looking for purple. There's still just 2 purples in there. Okay. Now I'm going to reduce this before we do any math. 2 goes into both. So that equals 1/3. Now to find the probability that we get both of these things to happen, we multiply them. So 5/7 times 1/3. 5 times 1 is 5. 7 times 3 is 21. That's our answer. Okay. Now this isn't a question, but let's say, just for example, if we wanted both blue, okay, it would start out the same, 5/7. Now if we did not replace it, there's 6 left. Now we're assuming we got a blue on that one. So now if we got a blue on the first one, that means there's only 4 blue left in there. Okay, so then this reduced just 2/3. And then the probability would be 10/21. So this doesn't have to do with the problem. This is just kind of an extra example just to show you that you're going to assume you got what you're looking for in the first one, and it could affect either just the bottom number or both the top and bottom, depending on what you're asking for the second one. Here we wanted the second one purple, and that didn't affect how many purples were in there when we chose a blue on the first. Okay, let's take a look at number 9. 2 urns, each contain green balls and white balls. Urn 1 contains 4 green and 6 white. Urn 2 contains 2 green and 2 white. A ball is drawn from each. What is the probability that both are green? Okay, so now, because there are 2 different urns here, these will be totally independent of each other. Okay, so to get a green from the first of all, how many are in there? 4 green, 6 white. There are 10 total balls in there. 4 are green. Okay, let's reduce that. 2 goes into both. So we get 2/5. So urn 2, we also want to find if we get a green out of there. Now it has 2 green and 2 white. So 4 total in there. 2 of them are green. That reduces to 1/2. Okay, so now to get our final answer, we multiply the probability of both happening. 2 times 1 is 2. 5 times 2 is 10. 2 goes into both. And we get 1/5. Okay. We're getting closer and closer to being done here. Number 11. Says 2 8-sided number cubes are thrown. So 8-sided. Given that one of the cubes shows a 6, what is the probability that the sum of the numbers come up on the 2 cubes is a 5? Okay, so the first one we get this, we get a 6. Now we got to know what are we going to get on this one, and we want it to equal a 5. Okay, Now, there's not really much math to do on this one, because if we really think about this, 6 plus what equals 5? It would have to be -1. We're not having negatives on the number cube. Okay. 2 8 sets. So this, on the first 8-sided one, we get a 6. We'd have to get whatever number on the second one to add up to equal 5. Okay. The probability of getting a 6 on the first one is 1 out of 8. Probability of getting a -1 on the second one is 0 out of 8. There is no -1 on these. So we'd get 0 over 64, but 0 divided by anything is just 0. It can't happen. If you get a 6 on the first one, okay, we can't add up, we can't have them add up to 5. Okay, so that probability would be 0. It can't happen. All right, 2 left, 14. Nope, sorry, 26. 14, you have other problems that are like that. It says 2 standard number cubes are thrown. Given that one of the cubes shows a 3, what's the probability that the sum of the numbers come up on the 2 cubes is an 8? So the first one, we have a 3. The probability of that happening is 1/6. Okay. On the second one, what do we need here if we want the sum to be 8? Okay, well, 3 plus what is 8? We need a 5. Okay, so if we look at this, hold on here 1 second. We actually don't even need this. We just, it's already given, so we don't need the probability of that happening. Okay, so I read the problem wrong. Okay, so we don't even need to know the probability of that happening. We just know it's given that the first one is a 3. But this still goes here. What do we need on the second one to get the sum to 8? We need a 5. Okay, so now 5 is not going to be included in our probability. We need to know what's the probability of getting a 5. It's a standard number cube which has 6 numbers on it. One of those which is a 5. So the probability of rolling a 5 on that second number cube is just 1/6. So it looks like it could be harder to determine things, but it actually ends up being kind of just a simple, basic probability problem, because the first one says given that one of the cubes is a 3. Okay, we didn't need to find the probability of that. And the last problem, number 28, it says 2 representatives are chosen at random from a group of 140 students that has 70 girls and 70 boys. What is the probability that the representatives selected are either both girls or both boys? So one thing that's nice in here is that they have the same number of both. Okay, so this one can be a little confusing, but we start out and let's say there's 140 students. So the probability of picking one, let's say, it doesn't matter which one. Let's go with girls first. Probability of getting a girl is 70 over 140. Then that person is picked, so that leaves 139 people left. Now, we assume we got what we wanted on the first one, which is a girl. And if we need another girl, that means there's 69 girls left. Okay. Now we got to think about this. This would be out. We see this involved here, so let's not cross this out yet. This is exactly what we see here, so that might be the answer. This is not what we see. Okay. So, which one is it? Is it this one or this one? Now, if the question just said, what's the probability that they're both girls? Okay, this would be our answer. Or if the question said, what's the probability that they're both boys? Then this would work also. But we can have this happening if it was both boys or both girls. So the situation can happen two different ways. So we multiply it by 2. Okay. So a little tricky there. But that would end up being the answer. Okay. All right, so that is it. Again, went through a lot of kind of quick problems there. Some of them easy, some of them a little more difficult. Go through those, copy those down. If any of the ones I didn't make sense, ask a question. Otherwise, try some of these other problems or a bunch of them. If they're not making sense, let me know. I will quickly go here and just circle the problems I did. So again, you can look at what category they were in. We did 1, 2, and 6. So you can use these problems to help you do other problems first. If you don't want to ask right away, if you want to try figuring it out on your own. But again, if you can't get them, that's when you should ask. Okay, and then a few down here. So if you're looking how to do a problem in a certain category, look at one of the ones we did in that category. Okay. All right. Get those copied down, send me the pics of them. If you have any questions, let me know.